right, this is Trig Notes number 1. We are going to start a new unit on trigonometry. Trigonometry is a branch of mathematics that studies triangles and the relationships between the lengths of the sides of the triangles and the angles that are between the sides. For the purpose of this unit, we are going to be studying right triangle, trig. So the only triangles that we are going to be dealing with are right triangles. All right, in trigonometry, there are 3 ratios, or 3 trig functions, and they are the sine, the cosine, and the tangent. Our 3 ratios are all going to relate to an acute angle in a right triangle. We'll start with sine. Sine is abbreviated S-I-N, and you pronounce that sine, not sin. And the sine of an angle is equal to the ratio of the opposite side over the hypotenuse. Next we have cosine, abbreviated C-O-S. Again, you would read this as cosine, not cos. The cosine of an angle is equal to the ratio of the adjacent side over the hypotenuse. And finally, tangent, abbreviated T-A-N. You would read this as tangent, not tan. The tangent of an angle is equal to the ratio of the opposite side over the adjacent side. We can use the word SOHCAHTOA. Oh, I just spelled it wrong. Sorry. SOHCAHTOA as a device to help us to memorize our 3 trig ratios. You can see here that the S is sine. OH is going to be the opposite over the hypotenuse. C for cosine is equal to the adjacent over the hypotenuse. T for tangent is equal to the opposite over adjacent. SOHCAHTOA. Okay. A few things to remember. Okay? Number 1, the hypotenuse will never be an opposite side or an adjacent side. Also, trig functions refer to the acute angles in a right triangle. So we are never going to ask you in this unit what the sine, cosine, tangent is of a 90-degree angle. I'd like to go over 2 examples with you. The first example, just to work on some vocabulary. Here is triangle LNM. Opposite angle L is side L. Opposite N is little n. Opposite angle M is little m. Okay? Just to get used to some vocabulary, if I asked for the side opposite angle M over the hypotenuse. I would go to angle M. Opposite angle M is little m. And the hypotenuse is opposite the right angle, little n. If I asked for the side adjacent to angle M over the hypotenuse, I would go to angle M. Adjacent means next to. Now this side is also next to, but I know that this side is the hypotenuse. So the adjacent side of M would be side L over the hypotenuse, which would be little n. If I asked for the side opposite angle M over the side adjacent angle M, again, I would look at angle M. Opposite angle M would be little m. Adjacent to M would be L. Again, this is the hypotenuse. It is not adjacent. Next example. Now we're going to look at a triangle. I'm going to put some numbers on the sides. All right. Looking at this triangle, if I want to find the sine of angle M. Now, in order to do this, I need to refer back to my ratios, which is SOHCAHTOA. Sine of angle M, I go to my angle. I know that the sine is the opposite over the hypotenuse. Opposite of M is 4, hypotenuse 5. If I wanted to find the cosine of angle M, again, I go to my angle. I know that cosine is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. And finally, if I wanted to find the tangent of angle M, come to angle M. Tangent is opposite over adjacent. Opposite of M is 4, adjacent is 3. We could do the same thing and find the sine, cosine, and tangent of angle N. We could not do that for angle P because it is a right angle, not an acute angle. This concludes Trig Notes number 1.